Let's take a look at number 83C, where we're going to be using integration by parts, IBP. And the reason we're going to be using integration by parts, we see right away, we've got a product of two functions, x times the sine of 5 minus 2x. And so, that's a good indication in general. If you're looking at a product of two functions, you may try integration by parts. Keep in mind the antiderivative, you just can't take the antiderivative of x, which is 1/2 x squared, and multiply it by the antiderivative of sine of 5 minus 2x. So you just can't do that. That's incorrect. If you remember the product rule from derivatives, the product rule, right, the derivative of a product of two functions is not the product of the derivatives. Well, same with the integral of a product of two functions. It is not the product of the individual integrals. So how do you proceed? You need to choose your u, right? So remember, the integration by parts formula deals with an integral of the form, we say u times dv, and that is going to be uv minus the integral of v du. The hopes is that this integral here is easier to do, or we can do, compared to the original one. So you have to choose u in a way that it gets simpler when you take its derivative, and the dv has to be something you can integrate, and then hopefully this v du will be a doable integral. The acronym I gave you for choosing u in the videos was LIATE. L stands for log. There's no log function here. I stands for inverse trig. There's no inverse trig function. A stands for algebraic. There is an algebraic function. Anytime you have a polynomial or any function that's composed of products, sums, differences, and exponents of variables without any of the trig functions or log functions or exponential functions, right? That would be an algebraic function. So I'm going to choose u to be x in this case. Then what's left? The sine of 5 minus 2x dx, that has to be your dv. Everything else, you have to cover everything. U is easy. Then we differentiate u. The derivative of u is 1, right? Since u is x, so du is equal to dx, right? Du over dx is 1, so du equals dx. And then here we have to integrate, so you have to be careful. We integrate both sides of this. Integral of dv is just v. What about the integral of this? Some of you can do this substitution in your heads, and that's fine. Just for those of you that can't, it is a substitution. Notice I'm going to use a different variable than u because we're using the u over here in the integration by parts. So to avoid confusion, I choose a different variable like w. Let w be the 5 minus 2x, the inner function. The derivative of 5 minus 2x is -2, so dw is -2 dx. Multiply both sides by -1/2. We get -1/2 dw is dx. So dx is -1/2, right? dw, so there's the dx, and then sine of this is sine of w, right? So there we have it. The -1/2 can come out as a constant multiple. The antiderivative sine of w is negative cosine of w, and so then we have negative times negative is +1/2 cosine of w. Remember, w was 5 minus 2x. So that is the answer. V is equal to 1/2, and bring this back up here, 1/2 cosine of 5 minus 2x. Now, some of you can jump right from here to here without doing all the formal substitution notation, and that's fine. These are simple. I would say that's a simple substitution where the inner function is just a linear function. Okay, so you do have to get that 1/2 out there. You know how that is. And notice also, the fact that typically when we integrate sine, we get negative cosine, but because of this composition, right, the -1/2 times the negative makes it positive down here, and so it's +1/2 cosine of 5 minus 2x. Okay, so now we plug into the integration by parts formula, right? uv minus integral v du. So u was x, v was this stuff we found, minus the integral of v times du, which is just dx. Okay, I clean this up a little bit now. I bring that 1/2 out, and now we're looking at the integral of cosine of 5 minus 2x dx. Well, it's very similar to what we just did with a sine, right? Some of you, again, can do this in your head. if you do all the substitution just like we did before, we get -1/2 sine of 5 minus 2x. And so that's the antiderivative. So you do have to find this. Notice this integral we can do, unlike the original integral, which we could not do, right, on its own. We had to use integration by parts to get a simpler integral to do. And the antiderivative of that is -1/2 sine of 5 minus 2x. -1/2 times -1/2 is +1/4. And so the full answer is just copying that first part down. -1/2 times -1/2, +1/4 sine of 5 minus 2x plus the c. And there is our answer. Okay. So there is ways to check. Remember, anytime you say this is the antiderivative of what we started with right here, you could check by taking the derivative of this right here. Now you've got a product rule here when you're taking the derivative, and there's chain rules involved with the derivatives of these two. So it's pretty, it's a little complicated, and then you have to simplify all that down, and hopefully after you do so, you would get back to the original function. But again, integration by parts, you'll need to practice this. Lots of variety in terms of what, depending on what we have. Sometimes you have to use integration by parts more than once, right? So make sure you look at the examples that I worked out in the lecture videos and are ready to go come test time.